Let's start our activity today by opening up the PDF file that you've downloaded. Our activity today is called Best Fit Lines. And so we're going to learn about graphing lines over like real life data. What I need you to do is change this into sort of a split screen mode. So I'm going to click on the three dots at the top, go to split view. The other program we're going to need to open is called GeoGebra. GeoGebra should be loaded on your iPad. And we're going to open that one up, and that's going to be our other screen. It's got a graph that shows up, and that'll be useful for us today. What we are going to try to do, we'll zoom in over here, is we're going to try to get that little table of values, that XY table in number 1, to graph on this graph over here. So if you just tap on that graph, you can see that there's a nice coordinate plane. Down at the very bottom of that menu, do you see where it says Algebra, Tools, Table, and Spreadsheet? You're going to click on Table, and it'll create a little XY table for you to start entering those numbers. So in the X column, we're going to enter the 0, 2, 4, 6, 7 from the PDF. The inputs are 0, 2, 0, 2, 4, 6, 7, and then in the second column you can put your Y values. And maybe you didn't notice, but a point appeared up on this graph, right? That must be the point 0, 2. And actually, if you take your finger and scroll up that graph, you can see that all of those ordered pairs got graphed. Of course, we want to see them all, so maybe pinch to sort of zoom out so that you can see all the points. Another thing that's going to be useful for us in future problems is try this right now. I want you to pinch just on the y-axis. Try pinching the y-axis and see if you can just shrink and stretch just the y-axis. Try the same thing with the x-axis, just pinching on that axis only, just in case you want to just, readjust and see one axis bigger than the other. In this case, it's probably just enough to zoom in or zoom out. But get yourself a nice viewing window of those 5 ordered pairs. They're not in a perfect line, aren't they? They don't have a constant rise over run, but in general, they kind of look linear. So the best we're going to be able to do is sort of fit a line to those. It's not going to run right through all of those, and that's why it's called a best fit line. All right, so we're on to step B, and that is to type y equals mx plus b into the input line. So in GeoGebra, you're going to hit the algebra little calculator button at the bottom. In that input line, you're going to type literally y equals mx plus b. You don't have to fill in any numbers. Y equals alphabet m x plus b. And when you push enter, a line actually shows up on your graph. If you click on the graph, it'll make that keyboard disappear. You know what else showed up? If you kind of drag on here, you can see more of that input line. The other thing that showed up is a little M and a B slider, they call it. Why don't you play around with that slider? What happens when we change the M slider? What's going on up there? Do you see how that slope is changing from positive to negative to positive to negative? That's nice. We can also change our y-intercept from negative to positive to negative to positive. That's pretty fun. Our goal is to try to get our line to try to fit those points. I'm not sure why that point is highlighted. Oh, there we go. So can you just do your best to try to make our line fit over those points just as best as you can? And this is a little bit subjective because we're not using any mathematical formulas to do this. We're just kind of eyeballing it. There is a way to use a mathematical formula to do this, but we actually don't know enough math yet for that. So we're just gonna kind of eyeball it and try to get, I don't know, sometimes I shoot for just as many points above the line as below the line, although in this case, I feel like that middle point is just a little too high for the rest of them, so I'm mostly fitting to those other 4 points. Again, it's a little subjective, so you're just gonna do your best until you're happy with a line that generally follows those points. We might not all have the same answer, and that's okay. We're probably gonna be decently close to having similar answers, but I think that's what I'm going to decide on for this one. Maybe you have something a little bit different, but I think that's what I'm going to go with. Once you're happy with your line, what we need to do is get the graph to go onto our worksheet. And the way we're going to do that is we're going to go to the little hamburger menu up here, and it says export image, and you're just going to click on that, and we're going to copy it to the clipboard. Click over to your PDF where it says place graph here. Oh, I've got to go into edit mode. Do you see that little, did you see what I did there? Down at the bottom, there's like a little pen or marker icon. Click on that, then you're in edit mode. So now when I click on the graph area, it's going to allow me to paste that picture in. I'll allow it. So now I've got a nice picture of my graph that I can resize. And now my worksheet has a nice picture of that graph that I made. Sweet. Right over here now is where I'm going to put in what M and B I decided on. So again, using our little annotations tool, your Apple Pencil is going to work best for this. Your M, well, my M, I came up with 2.7. It says right on the GeoGebra app. My B is 1.7. Yours might be different. That's totally okay. And then my y equals mx plus b, or if we write it in function notation, f of x equals 2.7x plus 1.7 is my function. And then they're just going to have us play around with that line a little bit. So if there was an x value at 5, what would the y value be? It's sort of like making a prediction. In that table, if there was an x value at 5, what would the y value be? We can figure that out. In the same way, if there was an x value at 10, what would the y value be? 5 was kind of inside of our data values. They call that an interpolation. The 10 was outside of our data values. They call that an extrapolation. Just some fun facts. So we're going to type that into our calculator. Give me a minute. First one, I'm getting a y value. If the input is 5, the output is 15.2. And I can kind of look at my graph and see if it looks like there would be a point up there at about 15.2. I think so. And then the other one, I'm getting 28.7. So those are my two values for the function. F of 5 equals 15.2, f of 10 equals 28.7. One more problem and we are done with number 1. This one's called the zeros. It's another fancy name for x-intercepts. And you can kind of see where that line is crossing the x-axis. Well, what we want to do is we want to find where the function equals 0, or an x-intercept is where the y value equals 0. So we're going to take our y equals mx plus b. This time our y value is 0. That's what it means to find the 0 of a function. I want to find out what x value is the x-intercept, is the 0. So I'm going to subtract 1.7 from both sides. You can show better work if you'd like to. Get that x by itself. I need to divide by 2.7 on both sides. If I take negative 1.7 divided by 2.7, that doesn't come out very nice. Negative 1.7 divided by 2.7. I could write that as a decimal. It comes out to approximately -0.6296. I guess we could do it that way. We also could write it as -17/27. I don't like to mix decimals and fractions, so that's just sort of a little hack to make that work. And if you look over at that x-intercept, does it seem like maybe it's, oh, well, there it is. Our GeoGebra is calling it a root. That's another name for a zero. And indeed, it did come out to -0.6296. I'm glad we did the algebra, though. We do want you to show that work. Your job is to do the same sort of process on numbers 2, 3, and 4. Good luck. Ask questions if you need it.